Hey guys, Jay from RS Garage. This next video is a interview or conversation with a man named Tom Roberts. Tom Roberts has been a pattern maker for a number of years. So back in the old school, before computers, you had men that sat down at desks and they drew out what engines and cylinder heads and components would look like. And CAD came along and changed that landscape quite a bit, but nonetheless, it's an experience to sit down and talk to someone that's been in the game from pen and paper to current times. He's had his hands in a lot of very successful racing engines, both on OEM level and small foundry batches like Cosworth. So I went out there with the upcoming and highly exciting subject of the Dart 2JZ, and I wanted to kind of get his opinion on a project like that. So behind me is some Dart 2JZs that I've got here in stock, ready to go into possibly your build. But for now, sit back, enjoy, and learn something with me. So with the release of the Dart 2JZ block, I decided that it was worth a trip to Ventura, California to talk with Tom Roberts. Tom Roberts is a draftsman and pattern maker that has been doing performance castings for a long time. So you can reach back into Cosworth, Chevrolet, Ford, Aries, a number of producers of engine performance parts relied on Tom to be the draftsman and create the patterns to cast. Because billet is cool if you're making a one-off part, but if you want to serve the masses and have 100 parts available, 1,000 parts available, you got to do it in castings. So there's no way to fit all of the information and the history of castings in a digestible video. But Tom's going to tell us a little bit about what it takes to make an engine block. And we have a drawing here that Tom did, and we can peek at it. And I've got a component here that basically fills the void where, inside your engine block is a void like this that the coolant flows through to cool the cylinders and to feed the cylinder head coolant. So, Tom, take it away. What can you tell us about engine casting?
Okay, you begin with which engine are you building, and you get those basic numbers of where all your cylinders are and where your bolt patterns are and, where your oil drain backs are and what you want to do with it. In other words, you talk it over. Do you want to move the lifter angles for the head you're going to put on that block, or leave it at stock? I think there's only, probably 4 different lifter positions on this block drawing that we can machine it to. So we make bosses, we figure out, okay, the lifter has to go this way or this way. You make sure you have wall thickness for the lifter. In the same way in the water jacket. And like this isn't a good one, but see this, sometimes you have to clear for push rods and things like that. And you have notches where push rods go. You have, but you're always thinking of the water flow and the way you're bringing the water in, the way you're transferring it from the block through the gasket into the head, and making sure that you vent all your high places where your water transfers on the intake side of the head, so that it takes and it gets rid of the air out of the water jacket.
Yeah, the air is when you have, whether it be cavitation to the water pump or the coolant is vibrating in the engine, you're getting aerated coolant, you can get hot spots. And there are some engines that have notorious failures due to the inherent design of the cooling system. So
because they aren't transferring the water out of the head in the right place.
Right. Yeah.
Like the 455 Buick.
Or the small Chevys where they burn between those two cylinders.
Right.
Yeah.
Okay. in other words, running a 1/4-inch tube from the head out to the radiator, not going through a thermostat, not doing anything. All it's doing is bleeding the water out of the head, and that problem goes away.
Well, and cooling is something that the import scene as a whole really neglects, because we had a relatively robust engine to start off with, and if you're not racing that engine for a long distance, the heat doesn't really come for it. But if if you're drifting or road racing or going to Bonneville, cooling is a huge headache. And through that casting process, that's one of the places that in not only a production capacity, but in a regular street operated engine, that billet just moves away. And I know there are some jacketed billet blocks, I get it, but you're never gonna get the opportunity to engineer a proper cooling system like you can with a casting in a billet, because the space available and the tool paths and restrictions and so forth. So you get into something like this, and this is your water jacket system. But like Tom was mentioning, when you're doing castings, it's an entire complicated drawing. That placement of the oil dipstick and all these other things have to come into play right from ground zero. So how big is the engine? What is the bore spacing on the engine? How many cylinders does the engine have? How do the fasteners that hold the head to the engine and the fasteners that hold the crankshaft in the block, how much distortion do they present to those other components? I mean, it's an entire loaded question to just jump into castings.
Right.
So how much time do you think is in a drawing like this?
Probably about a week. But you're also talking with whoever you're doing this with or for. And you're talking to the machinist. Since I do the patterns, I talk to me. You go to the foundry, you talk to the foundry. If those three things are not put together originally, and the group of what they want from the block, in other words, what they want to do with the block. And so you get everything in it, but by bringing the foundry in on day 2 or 1.5, then they know what is going on.
Right. So, Dart being an experienced foundry that's been casting, if Dart is a new name for you, keep in mind Dart's been doing blocks and cylinder heads for decades now.
Oh, yes.
And they have an OEM level foundry. They're not working with a small place. They're not working with an offshore place. They're working with a foundry that creates long-lasting, engines, whether it be Cummins or Dart engines. I mean, this is a U.S. foundry that really can deliver a product. So, as you kind of get excited about these blocks becoming available, keep in mind that it's not a small lift to cast a block, and it's not a small lift to cast a block that doesn't have problems. And whether this leads into cylinder head work and an aftermarket cylinder head for the 2JZ, it's a little early to tell. There's a lot of speculation, of course, but it's exciting to have access to an aftermarket casting. And as we look over this engine, I want you to keep in mind that a lot goes into the casting of an engine and the scale of that production. But with the scale of that production and all the moving pieces, we can have a relatively affordable block to build off of and do it in numbers. Hundreds of these blocks can be produced now. You've got a core box.
Right.
And now it's time
a whole bunch of core boxes.
A whole bunch of core boxes. Now it's time to put whether it be cast iron or aluminum into that core box. How does that procedure go right? How does that procedure go wrong? And what can the team do to ensure a quality casting as a finished product?
You back up to dealing with the foundry that understands what you're building. And you understand where the core prints go to put the crankcase core in, to put the cylinder cores in, and the way you're interlocking all these, and the way you're interlocking the water jackets that also are locked in from the front core and the rear core. That's what these core prints here are.
Okay, so those are location plugs?
This is a core print that goes into like the outside of the block. You see your, typical, everybody's got them. The
freeze plugs.
Yeah, the freeze plugs. Okay, that sets in there. Then when you bring this in, you bring it down over this. You haven't set your cylinder core in because this is core print up here, and that lines the 4 cylinders, and they print into the main crankcase.
How many pieces like this would be involved in casting of a block?
Okay, you have 2 cylinder cores. You have a front core and a rear core, a crankcase core, and then you have 2 water jackets, and then you have your cope and drag mold. That's it. But sometimes we get into doing some really crazy stuff up in the valley. Right. And you end up with a core hanging up in the valley.
Okay.
And sometimes you hang that off of the cope, part of the mold.
Okay.
So you core print it up into the cope and you bolt it in. You bolt it in place.
And how long do these components normally last?
The core boxes can make probably, if you make it out of aluminum and then machine it, or if you make it out of plastic with aluminum frames, we've made over 500 with no effort without touching it again.
So a lot of work in the front load, but
Right.
once you're in production,
it's, you can CNC the front and the rear core box. You can CNC the crankcase. You can make them in aluminum, you make them in shell, you can make them in, whatever the production, is required for the part.
Okay.
If you're making, 100 parts, a day or a half a day, or are you making, 10 blocks a week? I don't, that depends on what you're ordering.
Right.
But, like when we're doing the design, you're looking at how big is the camshaft bearing? How much clearance do you want for the lobes?
Yeah, and how will that interfere with the rotator? For us, in an overhead cam engine,
and
we
that's
don't have
dealing
to deal
with
that
all
stuff.
the lifter locations.
Yeah.
But all these things come into the dictation of what you're building. Sometimes in the crankcase core, which goes up to do the cam tower, or on some of the engines they run this a separate core and hang it off the front and the rear. And that way you're running an enclosed camshaft.
Yeah, I've seen some of the cup car engines are enclosed like that.
And it's kind of what you're going to use it for, but those boxes are easier to make.
Yeah.
But you know what you want. And we've done crankcase cores like this one where we machine inserts to go in here and we change the cam height an inch.
Yeah.
To move it up from where it was stock to where, like the Ford is 6 inch 80 thou, I think. And so you have chains, you have sprockets that go for 680, where another engine may be, like 540 or 560 on cam height. But when you start putting more stroke in it, your rods are running into the cam.
Yeah. Yeah, for us, we don't have to worry about that because we're overhead cam. But that is another thing to think about, going into pushrod engines. You may move the cam up in the engine, shortens the pushrod, and gets the cam away from the reciprocating assembly. There are some OEM domestic engines that the camshaft will, and crank camshaft and connecting rods will actually interfere where you have to grind clearance into aftermarket parts. We don't have to worry about a lot of that stuff because we're overhead cam, but the opportunity to, whether it be create a better main hardware, a better main web, something that's going to add strength. You have the flexibility to add cylinder wall or deck thickness to make a more robust block, because, in its as delivered form, you had an engine that was just over 300 horsepower, and many of us are making 1,000, 1,500, 2,000 horsepower with these engines. So the opportunity to make a thicker, beefier casting, which you see it in the Dart block, it's 30 pounds heavier than the OEM block. And that's just material that is there to absorb abuse and to keep shape and stabilize components to be reliable through the bearing system, through the gasket system, and through cylinder sealing. Well, thanks for the education, Tom.
Yep.
And
All
I
right.
hope to see you next time I'm out in California.
Okay.